This is section 7. In section 7, we'll be moving from single sample hypothesis testing to double sample hypothesis testing. I want to start on the last page of section 6. And on this page, it's a decision tree where you're going to meet all the different branches of the types of hypothesis testing that we'll be doing in this course. So if you have a hypothesis testing question, you can start here at the top of the tree. Section 6, we discussed the left-hand side of this decision tree, the single sample or one population hypothesis test. And we went down through this test, whether it was a test of the means, and then we presented the hypotheses and the alternative hypotheses, or if it was a test for the proportions, then we have the proportion hypothesis test, and then the following t-tests for each one of those. In this section, we'll be moving down the middle as well as the right-hand side of the decision tree. So the middle part of this decision tree are testing for the means. We're going to be looking at two populations. We're going to be first asking the questions, how are the populations related, independent or paired, and then based on that information, we can decide what type of test we want to run. And we'll show you how to do that in Excel. On the right-hand side of this decision tree is the population proportion difference. So if we have two populations with different proportions, we would go down the right-hand side of this decision tree. So given that, let's move on to section 7. So in section 7, we want to know something about the differences of two populations. An example would be the average number of patients admitted on Friday versus Monday. Is there a difference between the two? Or the average market share of brand X versus brand Y. A common two-sample hypothesis test that is commonly used is the difference between men and women's salaries. Now these are what are called independent samples, meaning that you have a group of men and that group or that sample is independent from the group of women. Typically, in most professions, not all professions, but most professions, we'll see a distribution of women's salaries, with some women in the high areas of their distribution, some women in the low areas of the distribution. And then we'll also see men's distribution of salaries. Now I've drawn this rather extreme. It's not quite this extreme, but we do find that on average, men's salaries tend to be statistically higher than women's salaries. Now, we're going to revisit this when we get into correlation and regression and show that that difference really doesn't have so much to do with their gender as it does to do with their self-selection into their career. In a two-sample hypothesis test, however, we would measure the mean of the first sample, the mean of the second sample. We could draw a confidence interval around the two samples. And when those confidence intervals don't overlap, we would state that these two samples are statistically significantly different. Essentially what we're doing is we're taking the mean of the first minus the mean of the second, and we're asking the question, is the difference between the two means equal to 0? If it is, then there's no difference between the two means. If it's not equal to 0 or something greater or less than 0, then we would say that there is a statistical difference between the two. So let's talk about the difference between one and two population hypothesis testing from our 6-step process. So the first step is that we have to calculate the means of the sampling distribution. If the samples are independent, the standard deviation of the sample distribution is the standard error of the statistic. We can see that we measure the standard error by taking the standard error of the difference. This is the standard, or the variance, or the standard, the square of the standard error of the first plus the square of the standard error of the second times, and then take the square root. The sampling distribution is normal for both large samples because of the central limit theorem, or if both population distributions are normal, then by the central limit theorem, the same way we would find that the differences between the samples are also normal. Now I need to make a special note here that the difference between the means is sometimes called the mean of differences. And we can apply the ideas of sampling distribution of the mean to the differences between the means, since by itself it really is normally distributed. Now that's kind of complicated, and a lot of what I just mentioned we'll actually kind of gloss over as we use Excel to follow these. So going back to our flow chart, we're going to first look and ask the question, is it 1 versus 2 sample tests? Is it a mean versus a proportion? And then finally, if it is a means 2 sample, is it independent or paired? So from section 6, we have a generalized format for all 3 tests. The generalized format is that we have some sample minus some hypothesized value divided by the standard error, and that gives us the number of standard errors that one is away from the other. The single sample t-test is performed just this way. We take the sample mean minus the hypothesized or population mean, and we divide by the standard error, which is the standard deviation divided by the square root of n. And that tells us how many standard errors the sample is away from the population. In 2 sample hypothesis testing, we're not comparing it relative to a hypothesized mean, we're comparing it relative to another sample. So in an independent t-test, we would really be asking the question of the sample minus the sample, hypothesis minus the hypothesis, but our initial null hypothesis is that the population proportions are equal. So that becomes 0. So the test is really measuring, or the t-statistic is really measuring, is the mean of the sample of the first sample minus the mean of the second sample equal to 0, or is it not equal to 0? We divide by what's called the pooled variance. Now this is essentially the average of the variance of the 2 samples. And we'll discuss in more detail about how we handle the pooled variance based on how much difference in the variation of the 2 samples. Now paired t-tests are fundamentally different. Paired t-tests, we're not asking is the mean of the first different from the mean of the second. We're comparing each individual observation, and we're saying, is the first observation different than the second observation, or is the mean of the differences equal to 0? Now, this is very critical because the way we measure a t-statistic based on an independent t-test is different than the way we measure a t-statistic on a paired t-test. We'll go through several examples, so hopefully you'll become familiar with the difference between a paired independent, or excuse me, an independent t-test and a paired t-test.